Hello and welcome to a new tutorial about mandatory occupancy simulation model. My name is Saeed and I am very glad that you are still with me. We have extensively talked about activities and now it's time for us to get into the most exciting part, which is the simulation itself and the scenario. In this tutorial, I'm going to talk about tasks and the scenario itself. As I have promised before, we are going to have a hospital layout as an example. However, everything we will see in this tutorial and the tutorials after this will also be applicable and usable in any other mandatory simulation model. I have chosen a simple layout for the sake of demonstration, but you can use it in a more complex set of layout in your own projects or works. So this layout has a nursing station, 6 patient room, patient 1, 2, 3, 4, 5, 6, a medical supply room, and a storage unit. So let's see what is the big picture. The big picture that we have is actually illustrated in this slide, and it's the only slide that I'm going to show you. So a scenario contains base stations and a bunch of sequences, which is a sequence repository at the right-hand side of this slide. Base stations are like the areas that if a nurse is actually the agent in our case, when there is nothing to do, the nurse goes to the nursing station and engages with the tasks that have the lowest priority. And there might be multiple nursing stations. In that case, the nurse will choose the one which is closest to her. Closest is actually a very simplified word. The real concept is that the most conveniently accessible. Sequences, on the other hand, in the sequence repository are nothing but a list of activities. A list of activities that serve one purpose and gets one job done. So a sequence, in this case, we have a repository of activities which contains activity A, B, C, and D. We have sequence A, which contains activity B, A, C, the order matters. And we have another sequence which is sequence B and it contains activity D, A, and B. So we can create multiple sequences, or in which in a sequence an activity could be repeated, but it will serve a purpose. So let's get into the real example. So I have created the OSM model to save some time, and so what I'm going to do first is actually to go to activity menu and load the activities from an external file that I have prepared to save time again. And so this should be fast. There should not be many activities. And I'm going to actually get rid of the grid from the view as well to make it simpler. So if you want to see the activities, you can go to the Create New Activity menu, and the activity areas, the existing activity areas would be highlighted. Nursing station, bedsides of the patients, and the medical supply room and the storage room. And when you have initiated the OSM environment, the scenario is actually created for you, but you have to edit that. So let's take take care of the base station, in which in this case is the nursing station itself. As I said before, you can have multiple of them. And then in here, you can create an activity. So first of all, you should give the activity a name. Let's say that this is going to be a simple periodic visit to a patient. So we will call it patient 1 simple visit. And it only contains one activity, which is this is the activity repository. And you can highlight the activity, hit the arrow button, this sequence also has a period of repetition. The period of repetition is not exactly 15. It's an exponential distribution with the mean of 15. If you are not familiar with exponential distributions and why it should be exponential distribution, you should actually find the statistics book and uh, take a look at that or consult one individual who knows about that. So in this case, 15 seconds is not a realistic number, but this is going to be for the sake of presentation only. And let's hit generate. So now we have one patient simple visit activity, and you have the chance of editing that activity later. We will not do that. We will create another activity for patient one, another sequence, sorry. So this is going to be patient one taking medicines. And in this case, it starts with going to the medical supply room, visiting patient one, and going back to the nursing station for documentation. So as you can see, this is a tedious task, and it cannot be based on hypotheses. We are talking about an isolated simulation model, but this data is actually very important, and it should be based on facts and evidence. So this might repeat itself every 30 seconds or every, I don't know, 60 seconds. And let's generate that. So this is a task combining 3 different activities with each other. Let's also create a new one, and we will call this one patient 1 throws up. Well, that's very unfortunate, but that's expected to happen in hospitals, in intensive care units. So in this case, everything starts with recognizing patient 1 to throw up. And then after that, the nurse will go to the medical supply room probably, and to get medicines. It will go to the storage facility to get some clean sheets. It will go back to the patient room to deliver the service, and finally it will go to the nursing station for the documentation of the whole process. This will probably repeat itself every 5 minutes, let's say, or I don't know, let's say 5 minutes, which would be equivalent to 300 seconds. Let's generate that. And then once we hit the finish button, you can see that we have created a queue, and in this queue, every one of these activities is actually highlighted with some time associated to them. And these times are actually important because they will show the priority in the queue. So once this activity gets, this sequence gets triggered, it will be performed, and after that it will be reactivated and put back into the queue again. Let me actually show you how it will work. So I'm not going to save this, sorry. And we can go to the mandatory scenario menu and then hit on the mandatory navigation control panel. So you can locate the agent. The agent will be automatically located in an area, in a base station area, which is in this case the nursing station area. I'm going to make it a little more visible so that you can see that. I'm sorry if you don't have a very good view of the whole setting. I hope that you do. And then you start the simulation. And as you can see that the agent is free at the bottom ribbon, and then the sequence patient 1 taking medicine is actually activated. You can show the destinations as well in here. So these areas will be highlighted. The one which is current target will be actually stronger than the others. And you have the chance of setting some other properties. So you have the possibility of changing the physical properties, so you can increase the speed of the agent. You have a control over acceleration, magnitude, angular velocity, body size. I don't recommend that you change the body size. And body elasticity and visibility angle. So these physical properties can be changed in here. So for instance, I am actually now changing the visibility cone of the agent. And you can see that it's actually dynamically changing as I'm changing these values in here. You can change the barrier repulsion range, maximum repulsion range, and barrier frictions. So I don't recommend changing them arbitrarily. We can adjust them later. I will teach you how to do that with the training scenarios. And for visualization, you can see the closest barrier to the agent and the barrier repulsion trajectory as the agent moves. You can see that we dynamically keep track of that. And we can actually also see the view of the agent itself. It takes a while for us to load it. But once it's loaded, you can see that the view of the agent is actually also available in this panel. You don't have to do that if your computer is slow. And well, you can hide this window entirely and focus on the simulation itself. But if you do that, then you can actually retrieve the window back by clicking on this arrow. And this is pretty much about the visualization part of this simulation. And you can stop the simulation anytime. And once you have stopped the simulation, you should clear the agent as well, and then you close the window. And once you have done all of that, you can go back to the mandatory simulation scenario, and you can go to the edit scenario. So the problem right now is that not only the numbers are not very accurate, which this is for the sake of demonstration, but the other problem is that the nurse had been assigned to one agent only, one patient only. Well, all of them are agents, hypothetically. So how can we fix that problem? We can come to this menu and we can create the sequences individually. This is a tedious task and it's prone to mistakes. But what we can do, we can actually save these guys in a text file, and then we can use that text file in order to create new activities. So I'm going to do that. And so I'm going to save all of the sequences, and these are going to be patient one sequences. And once you have done that, you will navigate to the folder that you have saved it. You will open this file with a text editor. In this case, I'm using Notepad++. And sorry, this is the wrong file. So it was patient one sequences and edit with Notepad++. You can see that this is the name of the sequence. This is the sequence tag, name of the sequence, its duration of activation, and the activities that it contains. So I'm going to actually copy this part of the file, create a new file, and put them in here. I'm going to copy patient 1, Control F in order to go to replace menu and replace patient 1 with patient 2. Replace all, and then I'm going to copy them back at the end of this file. I'm going to repeat this process to create the same sequences for all of the patients. So I'm going to put U the video on hold and I will come back with the completed list. Well, I have made some other changes as well. So I have actually filled this file with the same scenario, with the same sequences for different patients, first of all. And secondly, I edited the time interval for the activities. So for simple visits, it's every 2 minutes, in other words, 120 seconds. And for taking medicines, it's every 1 hour, which is 3,600 seconds. And every half an hour, there is a throw-up scenario as well. After you're done with that, you can actually save this file as a new sequence file, or you can just simply save it as it is. It's the naming is not actually very meaningful. Patient one sequence, it should be all of the sequences in our scenario. So it doesn't matter for our case. And so what I'm going to do is actually I'm going to remove these sequences and reload the sequences from the file. So I'm going to load the sequences from the file. So these are all of the patient one patient sequences, and it's quickly filled with the scenarios, with the sequences. And you can close the window, and the queue is actually much longer, as you have seen. But what you can also do is actually to visualize each of the sequences individually. So let's just start with, for instance, patient 4 through up scenario. So this is going to be patient 4. So if you visualize it, you will see that it starts with the detecting the patient, going back to the nursing, to the medical supply room, and then the storage, visiting patient 1 again, patient 4 again, and then going back to the nursing station for documentation. Well, you can switch back to another another sequence or another task, and in this case taking medicine. It starts with the red activity area, and then goes in the medical supply room. The nurse afterwards goes to visit patient 1, and then goes back to the nursing station for documentation. And you can clear that from here, and then you can run the simulation in a similar way. But what we are going to do, instead of visualizing that, we are going to simulate that. And for simulation, first of all, we should give it a name, and I'm going to call that simulation 1. And so the simulation will be stored as a field of data. Because it's a physically based simulation, it needs the time step for simulation, which is 17 milliseconds. So every 17 milliseconds, it will be updated. Let's actually make it 20. It's nicer because we don't want to visualize it. And then the duration of the simulation is 4 hours. Let's make it 6 hours. And so once you hit the calculate button, it will run on the background. At the time that it's running, you can do whatever you want to do in here. You will be prompted with this message after the simulation done. It says that simulation 1 was added, the runtime, and each hour of simulation, which is um, um, in each second, almost 1 hour of the simulation has been done. So this is much faster than visualization itself. Visualization is interesting, of course. And now we have a new field of data. So if you go to the data control panel, you have simulation 1 in here, which says that it had been simulated for 6 hours with the time step of 20. During the simulation, the nurse has walked this the nurse has walked this distance based on the unit of distance of your model, and the time spent on walking is actually 39% of the whole time. The time in the main station was 32% of the whole simulation time. So you have the whole simulation time, which is 6 hours. And the activity engagement time was 28% of the time. So we will actually not have enough data for the rest of these fields, but we will be talking about them later. You can actually go ahead and visualize your simulation data. So your simulation data, if you don't blur it, it will look very noisy, but you can still see that. So this is your simulation data. And if I put the grid on the top of that, uh, let me actually do some other tricks as well to make it. So you will see that there are some signs of walking trails and the time that is spent in different areas. This is not very interesting. So I'm going to actually do something, and I'm going to smoothen the data with the neighborhood of size 7. So we have to select the data field that we want. So this is simulation 1. And in the parentheses, because I want to know that this is the smoothened data, I will put 7 and then hit apply. You can increase the neighborhood size if you wish. And then in the visualization, you will have a better idea of what you are dealing with. So we will actually, instead of simulation 1, we will use the blurred version of that. And we will also put some texture for the clarity of visualization. So let me tell you what is the interpretation of this data. So this data means that how much time the nurse has spent in each of these areas. So for instance, this part of the walking trail has been raised a little bit, and you can see that this part is actually the part that this is part of the walking trail. This is the bedside of patients. You can import the model in here as well to have a more realistic idea or more accurate idea of the uh, areas. So this is bedside of patient 1, and this is how much time was spent in, patient 3, and how much time was spent in here, how much time was spent in each of these areas. And we can calculate, or we can narrow down the scope and calculate each of them individually. In the rest of the simulations we will see. But currently we can see that most of the time is actually spent on the nursing station itself. And then some time is also spent on medical supply room, and some time in the sorry, I got lost. Let me zoom out a little bit. In the storage facility, these like cone shapes are really similar in size, which means that all of the patients have been really the same because the scenario actually dictated the same thing. And we also have the possibility of visualizing that in 2D format. And if you want to do that, it's actually simple. It will be visualized in here, but you don't see much of the details of the walking trail in this type of visualization. So I like 3D visualization better. So this is it for this tutorial. Thank you for watching, and I hope that you have found this video educational and hopefully entertaining. See you in the next tutorial. We will be talking about combining visibility and a scenario in the next tutorial, which is very exciting. See you later.